All right, last one, guys. Same idea. We're gonna measure the length of our focal point to the front edge. I get 2.65, maybe 2.68 centimeters. So we're gonna go 2.68 centimeters the other way. Yeah, right, try to get the 8 exactly. We'll just approximate it here. All right, so there's our center of curvature. Remember, if your ray diagram is off, it is probably due to this ray because you drew this dot in. So we're going to go in and out through C from the top of the object into the mirror and out. Dotted behind, so in and out. Notice I'm putting the arrows showing the direction that the light ray is going. Then we're going to go in parallel, so lining up the top, in parallel, out, so see it's getting kind of crowded in here, out through the focal point. So we're going to go out this way, out through the focal point, and so we know these guys are intersecting like really close to the mirror. In through the focal point. So line up the top with the focal point. Are we going to go through the mirror? No, we're going to stop when we hit the mirror. Be careful. Stop when you hit the mirror. And then from that spot, go out parallel. You see how I'm being careful and I'm lining these things up? So we're going to go out parallel. And our last one, we're going to go in through the vertex. This one we very much have to extend so that we can measure it. In through the vertex. And our angle of incidence is going to equal our angle of reflection, so we need to line up our protractor. 10, 20, 30, 40, 50 degrees. So now we're going to go 50 degrees the other side. 10, 20, 30, 40, 50 degrees. Label them with their angle measurements. 50 degrees. 50 degrees, and then this guy should meet up right there with the other guys. So you have like a target spot. You kind of know where it should go. And if you did it right, it does go. And voila, look at that. There's our image right there. And it is virtual because it's in the mirror. It's made out of fake light rays. It is upright, and it is a wee bit reduced, if you look at that. Reduced. Okay, if you do the 1 over F calculation with it, 1 over F equals 1 over DI plus 1 over DO. We measured our focal point, and we found that it was 2.68 centimeters. Okay, it's a convex mirror. See, your focal point is back here in the mirror, so it's a fake focal point, so it needs to be negative. Is equal to 1 over DI, we're going to solve for that, plus 1 over, okay, how far is our object from the front of the mirror? It is 0.80 centimeters. And if we do the calculation, we get that DI equals 0.616. And so when we go and measure this, oh look, he's point, count, 1, 2, 3, 4, 5, 6 centimeters from the leading edge of the mirror. So that tells us that we did it right, and it came out negative in the calculator. which means it's back here behind the mirror and it's virtual.